Hello and welcome back to the channel. Today we're going to look again at Sleeping Warrior. Anthony Riley continues to excel at idiocy. Actually, I will take this opportunity to say congratulations, Anthony. I was so pleased to see that you won 2019 Dumb of the Year. The only thing is, you seem to be too stupid to realise that having won, you're not eligible for 2020. But hey, it's fun. Maybe they'll start a special category for you. Anyway, before we go on, quick thanks to my patrons. As always, massive thanks to all my patrons, including new patrons Corpus Defectus, Tiffany Hall, Erebathron, Bardtail, Francis Chimenti, William Foley, Alice Vangstrom, John Roswell and TechBlog, and my very latest patron, Pyro Kitty Cat. Thank you all so very much. So Anthony posted a video and he entitled it, "Not one baller can or will explain this. None of them. Why?" Well, this sounds like quite a challenge, especially as my face was one of the faces he put as part of his thumbnail. So come on in, Anthony. Get to it. Roll VT.
Okay, boys and girls, today we're going to look at the video most recently presented on the Quantum Eraser channel. The original video is linked in the video. It's BMLS69 or something like that. Forgive me, I forget the guy's name. It's a weird name.
Okay, so some guy made a video which was on Quantum's channel, and now you're playing it. And now I'm playing it. Okay, at least we all know where we stand. Go ahead.
And I'm playing it in reverse because I want to demonstrate what we can see. We're looking at these two platforms and you'll observe a little boat, a very small boat that's in the water in between the two platforms. It's got a little light on it.
Yep, I can see the two platforms. I can see a little boat with a little light on it. All is cool so far.
This is what we're looking at. Now we're looking at these two platforms from an elevated position that is not 1 foot above the water level. It's an elevated position. It doesn't matter what the height is for this one. We're not relying on this observation.
Okay, we got that. And as you say, it's quite obviously not 1 foot above the water. Again, carry on.
Because I'm playing the video in reverse, you're going to see the guy walk backwards down the steps. Obviously, it's in reverse, so don't panic about why this is in reverse. It's just to show what we should be seeing at an elevation and then compare what we do see when we look down 1 foot above the beach.
Okay, I've got that. And just to be clear, the video on your channel is uncut. It was indeed uncut. I've had to make snips to allow me to speak, and also I've cut out a few little bits that are just not applicable.
So again, we're focusing on these two platforms. We've got oil platforms in the distance, and we can see clearly that the horizon is behind both platforms.
Well, it's a little fuzzy, but yeah, you that's fair enough. You can see the horizon is behind those platforms. I'm not going to dispute it.
Now, if the Earth really is a sphere, and the elevation height is as critical as people like Miles the Liar Davis tell us, then it has to be the case that the horizon will prove that we're on a sphere, because the horizon will come towards us as we reduce the ability to see behind the curve because of our elevated position.
Absolutely right. The higher you are, the further you can see. I don't dispute that. And by the way, I just want to say, Anthony, you, on this video, are going to bust your own arse.
It's intuitive. We can all understand that the horizon would pass towards us, and that because of our elevation change, the platforms would end up being behind the horizon.
Well, that is going to depend how far away they are. If they're only half a mile away, then there's no way they're going to be behind the horizon. But I suspect you'll come on to that.
When he gets to the beach, he's going to drop his camera to 1 foot above the surface of the water.
Oh, that sounds good. So he was at an elevation before, and now his camera will be only 1 foot above the water. Cunning. And this is where I snip a couple little bits out just to save some time.
When he's at 1 foot, he looks at the same 2 platforms.
Well, that's just as well. It wouldn't be very repeatable if he's looking at something else.
We'll come to the distances shortly, but I want you to notice where the horizon actually is relative to the 2 platforms.
Oh yes, Anthony. We'll make sure that we're aware of where the horizon is. Most definitely.
Because if we are on a sphere, the horizon has to come before the 2 platforms, because that's it's the intrinsic part of gaining elevation. The horizon gets further.
Those are your words. They're correct words, but your words. Remember them.
So when he's a foot above the water, which we'll agree he's not really a foot, but we'll say he's a foot, the horizon must be in the foreground and both the platforms must be behind the horizon.
No, that is going to depend on many factors, not least of which is the distance to those platforms, which you haven't yet given to us. Right now we don't know what that is, so we have no idea whether they should or should not be beyond the horizon.
But we can clearly see that the horizon is behind the second platform, and we still see the boat in the middle.
Yep, I can still see them both, and I can see the boat, and this picture is a little murkier, but yeah, I can make out, I think, that the horizon is, as you said, behind and beyond both platforms.
The horizon being behind both platforms kills the globe.
Au contraire, mon capitaine.
And what I want to demonstrate is the analysis to this, because we did this on Ballbusters on Quantum Eraser channel recently, but I can do it better.
Well, I missed that one, but I'm glad to hear that you think that you can do it better.
More succinctly and more concisely, just by adding some layers to the video that we see.
Well, if it helps clear things up, I'm all for it, Tony.
So let's take a frame of where the horizon is, and it's roughly centre of the picture. And we'll go with this one. Happy days.
Oh yes, very happy days.
But we can see clearly that the horizon is still sat behind the second turbine.
Turbine? I thought you said there were oil platforms. Oh well. But yeah, again, it's murky, but I can make that out as well.
So let's add a little bit of contrast. We'll flip the imagery into negative so that we can see the converse, and then we can clearly see where the horizon is.
That does help a bit. Thanks, Tony.
Let there be no doubt. The horizon, the correct horizon, the real world horizon, is clearly and demonstrably behind the second platform.
Yes, Tony, and I'm not disputing that. You can see that the horizon appears to be beyond the second platform.
So now what we're going to do is we're going to put in the line for where the horizon is, and we're going to use this to pin a grid, a perspective grid that I've made myself, over the top, just so that you can appreciate the point that I'm making with the grid.
Well, that line that you added helped. Your grid is crap though. If that's perspective grid, why is it about halfway down the gaps start getting narrower again? You start off with them very close together, as they would be, due to foreshortening right towards the horizon. They're getting slightly bigger, then they get smaller again. But actually, it doesn't matter. I don't give two hoots for your grid. I don't need it.
The point is that whatever the distance to these, these platforms, we'll now remove the line, and you can just see the lines. And the idea behind them is to demonstrate that with distance, the gap between each mile reduces. Now, this isn't done to scale.
No kidding, it's not done to scale. And I don't think anyone would dispute that grid lines would appear to get closer together the further away they are from you, due to perspective.
There's been no maths in this. I'm just pointing the general principle out. As you look up to the horizon, per mile, the gap between each mile reduces. That's called convergence. It's a really important part of perspective. Ballers deny perspective.
Oh no, ballers do not. It's a case of flat earthers do not understand perspective. But that's for another day, because it doesn't affect the argument that you're going to make about the horizon.
They ignore this kind of stuff, but we realise that it's important. So the point I'm making with the grid is that we can appreciate that the lines that lead up to the horizon get closer together with every mile that you're getting towards the horizon. Quite intuitive, right? Makes sense. It's obvious. This is on a plane, of course. We know that we can't be on a sphere because the horizon's behind the second platform. We'll come to that shortly.
Well, I wish you would, because you keep claiming it can't be beyond that second platform, but you've given no logic, no evidence as to why.
So we're applying a flat plane grid. Now let's add the distances to the platforms. We've got the two platforms in picture, and you can look these up yourself to check the distances, but the first one, the nearest one to us on the right hand side, is Platform Hill House at 6.2 miles, and the second one in the distance, the one that's furthest away, is 9.4 miles.
At last, some actual facts.
We can safely conclude that the platform in the distance at 9.4 miles is before we see the horizon.
Yes, the horizon appears beyond it.
The horizon, the distance that you can observe this particular day, is beyond 9.4.
Yes, it is. And your own words are important. On this particular day.
Let's just say it's 10. It's far more than 10, but let's just say for this conversation it's 10. And now let's consider the begging the question, proof of nothing, perspective hijacking curvature calculators from Metabunk.
Okay, so now you're going to use a scientific calculator to work out horizons.
We can see that we can see at least 10 miles. We know that the observer height is a foot, and if we're looking at the horizon at 10 miles, if it's really a sphere, then we can see the horizon at 10 miles, but according to the curve calculators, the target that we're looking for actually cannot have a horizon anything greater than 1.5 miles away.
Tony, have you noticed there it says note? Not accurate for observations over water very close to the horizon unless the temperature and vertical temperature gradient are accurate. So there's a warning there, and you're just going to ignore it. But I'm happy for you to continue, because again, it doesn't matter. You're going to bust yourself in a minute. And yes, ignoring the warning that Metabunk gives, it comes up with a figure of 1.32 miles.
But we're looking at the horizon. But if it's a sphere, the horizon is only 1.32 miles away if you add for curvy light. And light doesn't even curve.
Well, light can curve, but again, that's something for another day. But ignoring the refraction and so on, as you are, that calculator is good for a geometric sphere. If we had no atmosphere, so that there is no refractional distortion, that horizon would be exactly 1.32 miles away, give or take any slight inaccuracies in rounding and etc. in the calculation.
So we're not going to accept curvy light. We're only going to apply the geometric, because the horizon on a geometric sphere is that close that we do not need to account for refraction at all.
That's right. If there's no atmosphere and no refraction on a geometric sphere, those are the figures that it would come up with. Only we do have an atmosphere. There is distortion. There is refraction. But please go ahead and bust your own arse.
That creates a big problem, because we do have the horizon at more than 9.4 miles away. But we see 9.4 miles because the platforms give us the distances. But if we're seeing 9.4 miles away at the beach at just 1 foot in elevation, then we cannot be on a sphere.
Well, if we're ignoring the atmosphere and refraction, it still wouldn't mean we cannot be on a sphere, but it would mean the sphere is a lot bigger than we thought. However, there is refraction, and that does make a difference.
Because the horizon is the furthest point we can see. But according to the Metabunk curve calculator, the horizon can only be 1.2 miles.
And yet, of course, on a flat Earth, you would never, ever see a horizon. You'd see an eventual blurring into the distance, but you would never see a crisp, sharp horizon. That wouldn't work.
This photograph demonstrates proof that we cannot be on a sphere.
No, 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 dear boy, it certainly doesn't, and I'll show you why in a minute.
Looming does not affect the horizon. It brings things back from behind the horizon, but we're talking about the horizon.
And refraction. Not looming, refraction.
So my question is simple. How is this possible on a sphere limited in size the way you tell us it is?
Well, I'm going to steer clear of the math, as you have done. I know my limits with regard to math, and this sort of thing is beyond me. And I'll quite openly and honestly admit that. If only you would admit your limitations too. I believe you struggled with the triangle, sides 1, 1, 1, and coming up with what the internal angles are.
Anthony, if a triangle has the sides 1, 1, and 1, do you know what the angles of the triangle are?
Which kind of triangle are you on about? Are you on about like a right angle triangle?
The triangle has sides 1, 1, and 1. Do you know what the angles are?
The angles would be... Well, it would be an equilateral triangle, wouldn't it?
Right, so what are the angles? Now I'm going to ask this again. If you have a triangle with sides of 1, 1, and 1, what are the angles?
I'm gonna pull up a triangle calculator.
So we all have our limits, whatever they are. But I don't need the math to show that you are wrong. I will use your own words and images taken from this very video to show you why the Earth is a sphere.
And I'll make the assertion that this does not conform to a sphere, because the horizon is the limit of our vision, and thanks to the platforms at 9.4 miles away, we can show that we can see from 1 foot above water. We can see the horizon is not 1.2 miles away, as predicted by the geometric limitations and restrictions of a sphere Earth.
Geometrically, with no atmosphere, it would be that sort of distance. There is atmosphere, there is refraction, there is distortion.
The Earth cannot be a sphere. Please explain this, dumbasses, because for those that believe in the religion of heliocentrism, this pisses all over your belief.
Oh look, there's me. I note, Tony, that you captioned that as whack a spack. That's disgusting. For those who don't know, spack is British slang. Spack is short for spacker, which is another word for spastic, which is a non-correct slur for those with cerebral palsy. Thanks for that, Tony. I think that that's beneath you. So, now is the time for you to get busted with your own words and images from your video. Well, let's start off with the screen cap, where you've put the grid overlaid on the image of the rigs taken down from around 1 foot above sea level. Now let's go back a little further to where you've just put the horizon line. Remember, this is a screen cap from your video. And here's a screen cap I've taken from the beginning of your video, where the filming was at a little height. We don't know what height that was, but it was up the hill a bit. Then we'll apply coloration to make the horizon easier to see. Next, we'll tilt it to get that horizon as level as I can by eye. Next, I've done the best I can to get that horizon line marked in, just as you did. Well, that's all tickety-boo, isn't it, Tony? Perhaps we should look at my image and your image next to each other. Well, I've aligned our marked horizon lines together as best I can, Tony, but there seems to be a bit of an issue. The pictures don't seem to match up. Let's have a closer look at the further rig, the one on the left. Well, on your image, the one on the left, the horizon line pretty much goes through the legs, perhaps half to 2/3 of the way up them, whereas on mine, on the right, it's way above those legs. On the left-hand side of it, it's at the bottom of the crane, and on the right-hand side, it's through the bottom of the body of the rig. Again, looking at yours on the left, on the right-hand side of it, that body of the rig is way, way above the horizon line. Well, perhaps we should look at the right-hand rig, the nearer rig. Remember, I have not adjusted your screen captured image at all. Now look at that horizon line. On yours, it's clearly going through, in fact, it looks as though it's even below halfway through those legs. Whereas on my image, on the right, it's well, well above the legs. Well, Tony, me old mucker, this is a bit of a to-do, isn't it? I think we should look at the two pictures side by side again and listen to the words of a wise person who can explain this to us.
It has to be the case that the horizon will prove that we're on a sphere, because the horizon will come towards us as we reduce the ability to see behind the curve because of our elevated position. It has to be the case that the horizon will prove that we're on a sphere, because the horizon will come towards us as we reduce the ability to see behind the curve because of our elevated position.
Oh dear, Tony. You use Metabunk's calculator, ignoring their warning about how it's inaccurate over water and close to the horizon, etc. Hell, you can see in those images from that video, the cranes on those rigs were all distorted. That all has an effect. No maths are required. Just the two different views from those two different heights allow you to see a little further around the curve, as you so eloquently put it yourself. You have busted your own arse. Well, I hope you've all enjoyed that. I'll look forward to seeing you all again soon. Until next time, stay sensible.
Shut up and sit down.